Right. So we can continue that the previous discussion of 3D trigonometry and geometry. So clearly a 3D shape here, and we want to compute these two angles, not just these two. So many angles you can easily compute, but it depends upon the planes. You choose planes. So first of all, I think about the bottom surface, this surface here. It's the first surface that we should focus initially. Then if I draw a perpendicular line to this surface, it will look like this, 90 degrees. And also 90 degrees. But now again, I can think about another plane, like, I don't know whether you can see this plane, another plane like this. That triangle is on that plane. Like this, on that plane. And interestingly, that plane is, I think, perpendicular. That plane. Triangle is on that plane. That's perpendicular because of the 90-degree angle here. That's the idea. Now, right. So to compute CAF, where's that angle? CAF and CFA. So to get that angle, I think we should think about a different. So what's the triangle? What's the suitable triangle for that angle, to get that angle? It's, I think, CAF triangle. Hence, I have to connect, I think, these two. But that's on the plane, on the plane. So CAF. Maybe let me shade the region. Now we are talking about this triangle, and that's 2D. Triangle is always two-dimensional objects. So the interesting question is, can you understand the difference between that triangle and CDF triangle? Can you identify the difference? That's a slight difference because it's a different plane, two different planes, right? But both planes, both triangles, perpendicular to the bottom surface. I mean this surface, this yellow colored surface, perpendicular. Therefore, this is very, very tricky, very, very important. Therefore, there's a 90-degree angle. Here, this is 90 definitely. And this one also 90. So sometimes it's hard to understand. 90. Now I'm going to draw that triangle here. 90. And this one, that's also 90. This is CFD, CFA. Two different planes, no issues. So now we did convert the whole thing to 2D. That's the beauty of this, because then you can do anything, right? So 7 centimeters. Now we need CAF, let's say theta, this one. And CA length, we don't know that. So what's the plan? To compute theta. So you need two lengths. I'm trying to use trigonometry. So to compute lengths, there must be a way. So computing CF is very easy. Compute CF through this triangle. Compute CF using trigonometry. But then we need another length. So this length is fine. AC or AF. I think computing AC is much simpler. For that, I'm going to use another triangle. Actually, this triangle. This one. That's also a right triangle because the bottom surface is a rectangle. Hence, this one's 9. The bottom surface, it's like your table. So 90. So basically, everything reduced to 3 triangles here, I think. I am using this triangle because we know a lot more about this triangle compared to other ones. So 7 here, 10 here. AC is using Pythagorean theorem. This is AC. And compute CF using trigonometry. Compute CF using trigonometry here. So I would like to write tan, because CF is the opposite, and hypotenuse always opposite to 90 degrees. So this is the adjacent. Please use tan 30. Opposite over adjacent. CF over 7. Apply cross multiplication or multiply both sides by 7. 7 times tan 30. Tan 30 is 1 over root 3. If I rationalize the denominator, I would get 7 root 3 over 3. So that's CF. And we found AC here. We are doing all of these things to compute AC. Now that AC length, so we are doing everything to compute CAF angle. So AC is 100 plus 49, 149 square root. So, so then here to compute theta, use tan. We don't need hypotenuse. We don't want to use hypotenuse. So use tan. So tan theta equals opposite over adjacent 7 root 3 over 3 over square root of 149. That is tan theta. To get theta, take the tan inverse. So that's the answer. You can use your calculator to compute this value. So I think I used the calculator. So that's 18.3 degrees, 18.32, 18 degrees. So not the answer. The most important thing is like identifying different planes. I used 3 planes here in this problem. Like this one, then a plane like, okay, let me use a different color. This plane, then the bottom. Like 3 planes. That's what we did basically. 3 planes, so 3 triangles. Those triangles on those planes. Then trigonometry. That's how you solve these problems. Right? Think about different planes. Maybe you can think about this triangle DAF, not for this problem, like experiment. And again, AEB triangle, this one. It's a different plane. And BCFE rectangle, it's a different plane. Then ADFE, that's another different plane, like that. You think about those things and more often try to draw those things. Not 3D figures, but 2D versions. How could you extract 2D triangles, 2D planes from 3-dimensional figures? That's the key. Or identifying 2D planes. You can color those planes. Yeah, right. Okay, thank you very much. Let's meet with a different video.